Welcome everybody. In this class we will start off by showing that this function f of x is equal to modulus of x times sine of modulus of x cube positive x is continuous at x is equal to 0. So foremost, let me state the necessary condition. The necessary condition for a function to be continuous. Now this is a statement: the function is continuous if and only if the limit of the function exists at x is equal to 0. So what does it mean? This means limit x tending to 0 of f of x should be equal to f of 0. Now you have to understand the difference between the left side and the right side. Here you are checking the function as x is tending towards 0. So the function is actually evaluated as x is moving towards 0. It can move towards 0. 0 is over here. It can move towards 0 either from the right side or towards the left side or from the left side. And whichever direction you're choosing, you are actually checking or getting the value of f of x. Now on the right hand side, you are obtaining the value of f of x at x is equal to 0. So directly you are substituting the value of x equal to 0 into the function and you are getting the value. So this is actually more like checking the system for a certain condition. Okay, say for example you are making a pot, right? This is a cooking pot for cooking meat and say making stew. You are saying this pot is strong, elegant, beautiful, and if you cook in this pot, you will enjoy the special aroma. You can name anything you want, right? And this is more like it will give you the Persian style of cooking. So this is your claim. These are your claims. That means this is what you are setting the value. You are setting the value of say x is equal to 0 and you are getting this value. This is your claim. But you are putting, or somebody is putting the pot on fire, right, with the meat, and the temperature is moving, say 200 degrees centigrade. Let us assume. So it is moving. This is the point. Of course, we know that water boils at 100 degrees, right? Now this is beyond the 100 degrees mark. Okay, as we move from 100 degrees, so that the cuisine is achieving its desired point. Okay, this is the desired level of softness and tenderness, whatever you want. From 100 degrees onwards, the temperature is moving towards 200. So that is a point where the meat achieves its say the real extremities of taste, to put it. But suddenly what happens? The material of the pot melts. Right? Now this is the limit. This is the limit. We are setting x is equal to 0. In this case, maybe 200 degrees. This is the limit that we want the temperature to hit. But concurrently, we have to ensure that the pot remains intact. So on one end, you claim this pot can hold at 200 degrees centigrade. But apparently we see here, as we are progressing towards that mark, the pot is melting. So this is what we call as reality versus presumption. You can replace the word presumption by assumptions or claim, anything for that matter, right? So when reality hits, the story is a different light. Okay, this is more to illustrate the understanding of what it means, limit of a function exists at the point that we are looking for. Now this is just one part. Now let me go to the next part. So this is the next part. I'm going to take another sheet of paper. So we have the f of x to be as modulus of x times sine of modulus of x cubed positive x. This is what we have got. Now foremost, let us evaluate f of x for x is equal to 0. So that means I want f of 0. So let me realign this quantity. I can rewrite this as modulus of x sine of, I take x out, so this is going to give me x squared positive 1, all with the modulus sign. I can rewrite this as modulus of x times sine of modulus of x times modulus of x squared positive 1. Fair enough, right? So now for x is equal to 0, we have f of 0 is equal to modulus of 0 times sine of modulus of 0 times 0 positive 1, which is going to be equal to modulus of 0 times sine of 0, which is going to be 0. So this means at x is equal to 0, f of 0 is equal to 0. So this is the value that we have obtained. Now we will have to find a limit extending to 0 of f of x. Now since f of x is equal to modulus of x times sine of, I'm going to use it like this, modulus of, because we've already defined this, modulus of x times x squared positive 1. Now by definition, modulus of x is equal to x for x greater than or equal to 0, and it is equal to negative x for x less than 0. So clearly, when I have x greater than or equal to 0, I will have to study the values. So now the next objective is to find the value of f of x as x is moving towards 0 from the positive side. So this means I am trying to evaluate or getting the value of the function, what we call as the right hand limit. So let's do that. So for that, see, if you take the number line, we got x here, we are moving from the right hand side, so this is the positive side. So for x greater than or equal to 0, in that case I'm going to take the modulus value to be equal to x. So first we will have to set the function up. So f of x is going to be modulus of x is equal to x. So x will be there, and this is going to be sine of x is going to be here. Now over here, modulus of x squared positive 1 is going to be x squared positive 1. Why? Because x squared positive 1 is always going to be greater than 0. So this is going to be x squared positive 1, right? So this is what we have the function defined. Now as x is tending towards 0 from the positive side, limit of this function is nothing but limit of this function. So you set the limits x equal to 0, which means you're getting the value 0, right? Because sine of 0 is 0, and 0 multiplied with this component will produce you 0. This is as x is moving towards 0 from the right hand side. So this is what is called as a right hand limit. Fair enough. Now I'm going to go to the next paper so that you can have the frame in view. So now I'm going to take f of x. I need to define f of x for x approaching 0 from the left side. So you have the number line, 0 is here, so 0 is being approached from the left hand side. So that would mean our modulus of x is equal to negative x for x less than 0. So in this case we will have to have a new function. F of x is equal to modulus of x is negative x, and you have sine of modulus of x is negative x. So let me have that and place negative x. Now no matter which is, this is negative or positive, this has got a square there, so the outcome is going to be x squared positive 1. It's not going to have any impact. But sine x is odd function, so this means sine of negative x is going to be negative sine x, right? So this negative is going to come out, so my f of x is going to be x times sine of x squared positive 1. This is how it is going to look like. So this is in the same manner that we have in the earlier case. So now I can clearly write here, this is nothing but limit x tending to 0 from the left hand side. We need to check for x times sine of x times x squared positive 1. So applying limits, APL stands for applying limits. What do we get? We get 0. So this is the left hand limit. Left hand limit. So if I were to take this as 1 and take this as 2, what do we see? From 1 and 2, we have limit x tending to 0 plus f of x to be equal to limit x tending to 0 minus f of x. So the right hand limit and the left hand limit, or the left hand limit and the right hand limit, are equal. They are existing and they are equal. So this is condition 2. Now condition 1, if you remember, I took the functional value and I applied x is equal to 0, and I got f of 0 is equal to 0. I got this value. So if I were to take this as, say, sum a, from a clearly the function is defined at, I'm going to write the conclusion. This is the conclusion. From a clearly f of x is defined, because we got a value, is defined at x is equal to 0. What value we got? Since f of x is equal to 0 is equal to 0, this is acceptable. Also from above, or say 1 and 2, we know that the right hand limit and the left hand limit exists, and they are equal. So this means all required conditions for f of x to be continuous are satisfied. So this means f of x is equal to modulus of x times sine of modulus of x cubed positive x with the modulus sign is continuous. Okay, so that completes this question.